Okay, hey kids! We are going to learn or review area of an irregular figure. And let's think about what we talked about with an irregular figure. It's irregular, it's not normal, and we have to divide the figure up into pieces and try to find a way to make shapes of formulas that we know to find the area of those pieces and put it together. So we have this irregular figure here, and there are really two ways to divide this up. Well, I guess it could be three as well, but we'll go with two. We can divide it up drawing a line here and making a rectangle and a trapezoid. So I'm going to call this shape number 1, and I'm going to call this shape number 2. Now, when I show my work, I want to make sure that I start with a plan. The plan for shape number 1 is that it's a rectangle, so I'm going to use the area formula base times height. So I need those measurements, the base and the height. I'm going to use 9 as my base and 4 as my height. So 9 times 4 gives me the area of 36. And this is meters squared. Remember your label. Now I have shape number 2, which is a trapezoid. The trapezoid formula, the plan, would be to take the height and cut it in half and multiply that by the base 1 plus the base 2. So we need those parts. Now, I see a base here. Let me use a different color. I see a base, and remember you're adding the bases together, so it doesn't matter which one you call base 1 or base 2. The bases are your parallel lines. So we have a parallel line here, which is parallel to this. We need this measurement though. So go back to what we know about a rectangle. If I have a rectangle, I know that this measurement here is going to be the same as this. So if I look at my figure number 1, which is a rectangle, this side is 9, which makes this side 9. So I'm going to fill that in right there. So there's my other base, I'm going to plug that in. So I have 9 plus 5 here. Now I need to take half of the height. So if you're kind of looking at this sideways, the height is here. I'm going to use red. Here's the height. Now the 11 represents the length that goes from one end of this complete figure to another. So that is not this red line here. You have to find that. And again, go back to your rectangle. If this is y, we know that this is y. So go back to your figure here. We have 4, which is this measurement here. We know that this is 4 here. Okay, I'll do that in blue. So you know that this is equal to this. If this is 4 and the whole thing is 11, we need the difference between the complete length and the segment that we have. So we would do 11 minus 4, which gives us 7. That's the red line right there. So now we have 7. Now, 7 is an odd number, and we're going to cut that in half. So that's going to give you a decimal when you cut that in half. Remember, top in, bottom out. And we get 3.5. 3.5. And if you already know that it's 3.5, you don't need to show that, but I just wanted to show you that at home, in case you don't know. Okay, so now we have 14. So order of operations, we do parentheses first. We have our division, and now we need to multiply. Remember, when you multiply a decimal number times a whole number, you multiply as you normally would, and then you count over however many digits are past the decimal, you count over that many places in your answer. So we have 3.5 times 14. Add your placeholder. We have 5. And we have 490. So the area of the trapezoid figure number 2 is 490. Wait a minute. Oh, 490, but then we have to put in our decimal point. We count over one spot, so we get 49. So now, the area of figure number 1 is 36. The area of figure 2 is 49. And so now, if we want the total area, think about this as your living room, or your living room and your family room combined. You want to know, if you were putting carpeting down, you would want to know how much carpet you need for that space. So we need to put this together, and so you're going to add the total area for figure 1 plus the total area of figure 2. So you would write down total area. Make sure you label everything so that we can follow your work. There's a lot of work here. So we have 36 plus the 49, and we get 85. So we'll call it TA for total area is 85 meters squared. Remember, area is always squared. So we took a complex figure, we broke it down into pieces, and we have area formulas for these pieces, and we plug in the numbers and then add it together. So we're piecing it together and adding it at the end. Now you try. You can do this. I know you can. Great job. See you later.